Picture this, a world where every farm is a high-tech laboratory, monitoring the very air we breathe. Imagine sensors silently working in fields, tracking invisible gases that shape our planet's future. This isn't science fiction. It's the cutting edge of agriculture, and it's happening right now. Welcome to the Fields of Innovation YouTube channel, where smart farming starts here. Discover the future of agriculture. Greenhouse gas emissions from agriculture are one of the most critical challenges facing our planet today. Farming is responsible for a significant share of global emissions, making it a key sector to address in the fight against climate change. At the same time, agriculture itself is highly vulnerable to the consequences of a warming climate, such as droughts, floods, and changing weather patterns. This creates a double-edged situation. Farming both contributes to climate change and suffers from its effects. The connection between farming practices and climate change is direct. Choices such as how we irrigate, fertilize, and manage soil can significantly increase or decrease emissions. That's why measuring emissions accurately is the first step toward making agriculture more sustainable. But what exactly are we measuring? The main culprits are carbon dioxide, methane, and nitrous oxide. Carbon dioxide, or CO, is released through soil respiration, tillage, and the operation of farm machinery. While it has a lower warming potential compared to other gases, it's emitted in large quantities, making it a significant factor. Methane, or CH, is produced in waterlogged rice paddies and fields associated with livestock. It's especially harmful because it traps heat more effectively than CO, intensifying global warming. Lastly, there's nitrous oxide, or NO, which mainly comes from nitrogen fertilizers. When fertilizer is overapplied or poorly managed, it escapes from the soil as NO. Although emitted in smaller amounts, it has nearly 300 times the warming power of CO, making it one of the most damaging agricultural emissions. Traditionally, measuring these gases involved taking soil or air samples and analyzing them in laboratories. While precise, this method has serious limitations. It's costly, time-consuming, and only provides snapshots instead of continuous monitoring. Farmers can't rely on such delayed results to make day-to-day management decisions. This is where sensor-based monitoring changes the game entirely. By placing sensors directly in the field, farmers and researchers can capture real-time data about emissions as they happen. This continuous measurement provides a more accurate picture of daily and seasonal emission patterns, making it far more useful for practical farm management. So how do these sensors actually measure greenhouse gases? They use a variety of advanced methods. Soil gas, flux sensors, and chambers capture gases as they move from soil into the atmosphere, allowing for measurement of CO and NO emissions. Infrared and laser-based detection technologies can detect specific gases, such as methane, with high precision even in open environments, providing rapid and reliable readings. When integrated with IoT platforms and data analytics, these sensors can transmit data in real time to cloud platforms. Farmers and researchers can then analyze this data through dashboards, receive alerts, and even automate farming decisions based on the readings. The applications of sensor-based GHG monitoring in smart agriculture are diverse and impactful. In fertilizer management, monitoring NO emissions allows farmers to adjust fertilizer application, applying only the necessary amount, which reduces waste and emissions. For rice cultivation, sensors and paddies help farmers track methane levels and adjust water management to minimize emissions without harming yields. On a larger scale, farms can use sensor data to measure and certify their sustainability efforts, supporting participation in carbon markets and adding value for environmentally conscious consumers. The benefits of this technology for farmers and the environment are multi-layered. It enables data-driven decision-making, moving from guesswork to precise, evidence-based management practices. This leads to cost savings and improved efficiency by reducing excessive fertilizer and water use while improving yields. Moreover, farms that adopt these systems actively reduce their carbon footprint, supporting both national climate goals and global climate agreements. However, despite its promise, the adoption of sensors faces real challenges. The high cost of advanced sensors presents a significant initial investment, which may discourage small or resource-limited farmers. Connectivity and infrastructure issues in many rural areas still lack reliable internet, making IoT-based monitoring difficult. Additionally, farmers need knowledge to understand and apply sensor data effectively, which requires education and extension services. Looking to the future, the outlook for greenhouse gas monitoring in agriculture is closely tied to technological progress. Artificial intelligence will play a crucial role, analyzing massive datasets from sensors, satellites, and weather models to predict emission spikes and suggest proactive interventions. Blockchain technology will enable transparent recording of carbon emissions and reductions, allowing farmers to trade carbon credits fairly and securely, creating new income streams. With the right subsidies, incentives, and international climate policies, sensor-based monitoring could become standard in agriculture worldwide. In summary, measuring greenhouse gases from farmland using sensors is a breakthrough that combines technology with sustainability. It allows farmers to improve efficiency, reduce costs, and protect the environment while contributing to the global fight against climate change. This innovation represents a significant step forward in our ability to understand and manage the complex relationship between agriculture and climate change. To our audience, if you found this information valuable, please like the video, share your thoughts and questions in the comments, and subscribe to our channel for more insights on smart agriculture and climate-friendly innovations. Together, we can cultivate a greener future for farming and our planet.